now we're going to look at the inverse function. So what is the inverse? Well, let's first of all look at the notation. So the inverse function, anytime we have an inverse function, if the original function is named f of x, then the inverse is denoted by this form here, f to the negative 1 of x. So this negative 1, all that means it's the inverse of the original function named f. That's all it is. That's just the notation. So whenever we're dealing with inverse and it's a function, we're going to be looking for this negative 1 notation. Now, we have to be very careful here when you're doing this notation, is we're not going to use this notation, f of x to the negative 1. This means something completely different. So we don't want to do this. We want to make sure we have that negative 1 before the bracket and the f. So what is an inverse? Well, an inverse is something that you've actually been looking at a long time. You just haven't really been told before and ever noticed. An inverse function, or we've also been dealing with inverse operations. And what they do is they just undo each other. Now, that seems like a pretty silly math word to use, to undo. But really what they do is one just reverses the other. So if you think about operations, two inverse operations are addition and subtraction. If we take something and add 3 to it, to undo that, we would subtract 3. Another inverse operation, multiplication and division. They reverse each other. They undo each other. So when we're dealing with functions, if we take the inverse of a function and we compose it with the original function, what we get is we get just x. That's how we can tell. If we're given two functions, we can compose them together. And remember, this is just the same as doing f to the negative 1 of g of x. Let's get rid of that red. So that's all that is. This is just f to the negative 1 of f of x, and this shouldn't have been a g of x. Let's go back and correct that. That should have been f to the negative 1 of itself, f of x. So that's just the notation and what the inverse is. So let's look at an example here. We have two functions, and we have to find out if they are inverses of each other. So what I'm going to do is I'm going to go back to these two functions, and these are called both y. So what I'm going to do is I'm just going to call the first function f of x. And f of x is going to equal x over 2 minus 4. And let's call the other function g of x, which is 2x minus 1/4. So recall, if these are inverses of each other, if we do f of g of x, meaning we take that function g and everywhere in x we take the function f and everywhere in x we replace it with g of x, this has to equal x for it to be a function. Now, what I can do is I can actually choose here. I can go f of g of x and put g of x in f, or I could do g of f of x. Both are going to work, because we're not concerned about what the solution is per se. We're just concerned if, when you compose them together, you're left with just an x. So the reason I'm going to do the second one over the first one is just to make the math easier. Take the function g, and everywhere in g there's an x. We're going to replace it with f of x. So it's going to be 2 x over 2 minus 4 minus 1/4, which is going to give us 2x over 2 minus 8 minus 1/4, which in all boils down is x minus 8 1/4. And I don't even really care what this last number is, because right away I know that this is not equal to x. And so if it's not just equal to x, these are not inverse functions.